Hello everyone, I welcome you to Mobile Fix Institute. In this video, I'm going to explain something very vital to you, very important. I made a promise on my last video that I'm going to make a video on divided circuit, how it works, because this circuit is very, very important for you to understand. Mobile Fix Institute, we are here to ensure that you understand why something works and how something works and how to make it work. So that is our goal. Our goal is to ensure that you don't only know what to do, but you know why you are doing it and how to do it. So in today's video, I'm going to explain to you how divided circuit works, so that when you are troubleshooting phone and you meet this type of circuit, you will know what to do and how to calculate. And also, in this kind of circuit, let me mention a few places that you will meet this type of circuit, that you will meet divided circuit. One of the places that you will meet divided circuit is your BAT ID line. You will meet divided circuit on your BAT ID line. Then also you meet divided circuit on your baton line, that is your BAT stem. Okay, then there is a line in charging IC. The line is called REGN line in MediaTek charging IC. So on that line, you will also meet divided circuit there. Okay, there are other places. For example, in MediaTek, you will meet a divided circuit on the external buck converter. Those two ICs, external buck converter, the 8-pin IC and the 6-pin IC, you will meet divided circuit. On the feedback lines, you meet divided circuit there. So this circuit is very, very important for you to understand how to calculate it, the formula, so that when you come across this type of issue, then you will know how to calculate it. Okay, now there are two kinds of circuit, but the one commonly used is this single divided circuit. I call this one single divided circuit, and I call this one double divided circuit. So most times we normally see this one single divided circuit, but in case you meet any model that carries this double divided circuit, there are a lot of models that carry this double divided circuit. So when you meet this type of circuit, you will also know that the formula for calculating single divided circuit is far different from the formula of calculating this double divided circuit. And I have put a formula here for you. Okay, now before I begin to explain this thing, there is what we call series connections and parallel connections. For example, there are a lot more to this. What I'm about to explain to you, there are a lot more to this. So I just want to explain it very briefly. For example, we have a line here. Okay, this is point A and this is point B. So now, if we have a component here that is connected in between this line, okay, we can call this series connection. Okay, because both lines, both ends are connected in between this line. Okay, so this is series connection. For example, if you see a capacitor in between a line, and this line is not ground, in between a line, so this is a capacitor that is connected in series. And most of the capacitors that you will meet connected in series, the capacitors are called fly caps. Okay, you see it on your fast charging IC. There are models that carry fast charging IC, so you will see fly caps there. Those caps are called pumping caps. They help to pump the ampere, because the phone for charge, the phone needs a lot of ampere to enable fast charging. Okay, so you also meet these fly caps on your display section. So it is called fly caps. So the fly cap is always connected in series. Okay, not only capacitor, you can also meet resistors connected in series. You can meet other components connected in series. Okay, so like diode is connected in series. Coil is also connected in series. So there are a lot of components connected in series. So that is series connection. Most of us know series connection, but for people that do not know series connection, that's why I explained this. Now, there's also what we call parallel connection. Okay, the first one was series connection. Then this other one is parallel connection. What is parallel connection? For example, in phone, we have two lines. Let's call it positive. Excuse me. Let me clean this. Okay, in phone, we have two lines. We have positive line and negative line. For example, the negative line, okay, the positive line is the line that the main voltage travels through. Okay, that's our positive voltage. Meanwhile, our negative line is connected to ground. So you see a sign like this. Okay, this sign signifies ground. So our negative voltage is always connected to ground. Now, when a component is connected in parallel, you see a component, you see a line. This is a voltage line. Let's call this our positive line. Okay, this is our positive line. Okay, now you have a component. If your component connects in between this line, it is called series connection. But if a component connects, one leg of the components connect to this line and then the other leg connects to ground, okay, this is parallel connection, because one leg is connected to the positive line and the other leg is connected to ground. So any component that one leg connects to the positive line and the other leg is connected to ground is called parallel connection. Okay, I hope you understand. So this is important for us. If we don't understand this series and parallel connection, we will not be able to understand how this divided circuit works. All right, so now let's explain this. There is a line that comes from the positive line, and then it will meet a resistor that is connected in series. This resistor is connected in series. Okay, and we can call this resistor pull-up resistor. This is our R1 pull-up resistor. Then it also connects to another resistor that is connected to ground. So this is our R2 pull-down resistor. This resistor is connected to ground. This is in series connection. Meanwhile, this one is in parallel connection because one leg is connected to ground, the other leg is connected to the positive line. Meanwhile, these two legs are connected to the positive line. Now, this is when divided circuit take place. When two components meet, especially resistor. Okay, when two components meet and then one component is connected in series and the other component is still on that line, one leg is connected to ground, you know that this is a divided circuit. And there's always a line that comes out in between these two components, in between these two resistors. There's always a line that comes out that is called our voltage out. So this is our voltage in and this is our voltage out. Okay, for example, if you see a line, you see a resistor here. Sorry, you see a resistor here and another resistor is here. But one leg of this resistor, instead of connecting to ground, this leg connects to another line that is not ground. This is not divided circuit. Okay, this is not divided circuit. But for a phone to be a divided circuit, is either this leg is connected to ground or you trace this line. Maybe this line might be connected to ground. Okay, so if this line is connected to ground, you know that this is a divided circuit. I hope you understand. If you don't understand, ask question. I'm going to answer. Okay, so we have a voltage for calculating single divided circuit. It's called V in times R2 divided by R1 plus R2. So you get your voltage out. So this is the formula for calculating it. So now to calculate this divided circuit, okay, you find out how many voltage is this input line. This is our input line. This line might carry 5 volts. Okay, this line might carry 2.8 volts. This line might carry 1.8 volts. Okay, so now in the case of BAT ID and BAT 1, because before I enter BAT ID circuit, how it works, we need to understand divided circuit. So most of on our BAT ID and BAT M line, the voltage range will be between 1.8 to 2.8. okay, voltages. Especially on our BAT online, you normally get 1.8 to 2.8, but on our BAT ID, it's often, let's say, 1.8 volts. So the input voltage might vary, okay? They might decide to put any input voltage. So the input voltage is not constant. So you must find out the input voltage, okay, to calculate this. Okay, for example, let's say in our charging section, in our MediaTek charging section, let's say analog charging section, we do have a divided circuit there. On our VCDT line, we do have a divided circuit. So let's take the value of those resistors that are always connected to that line. Let's say R1 should be, this is our formula. R1 is voltage in for that line should be, it's always 5 volts. So we put 5 here. That is our voltage in. Then times R2. R2 on that line is always 39k. Okay, so we put 39 divided by R1 is always 330. That's 330k plus R2 is 39. So let's calculate this. I hope you can see. Okay. So now let's say 5 times 39 gives us 195. Okay, then we divide this by, let's say 330 plus 39 gives us 369. So let's see the output voltage. So now after calculating this, you divide this 195 divided by 369 equals to, so it gives us 0.52. You can just put 0.5. So this is the output voltage that VCDT line carries. Okay, now if by any means this divided circuit is not working on that line, it's not giving out the required voltage 0.5, maybe the power IC is not sensing 0.5 volts, the phone will not charge. Okay, so this divided circuit is very, very important. So now I'm still explaining single divided circuits. So now let's take another value. For example, we have the input voltage is 5, then the output voltage, sorry, our R2 is, let's say, 100k. We divide it by R1 is still 100k, R2 is 100k, then R1 is 100k. So 100k plus 100k. So in this situation whereby you have R1 and R2 have the same value, it means that this input voltage will be divided into 2. Will be divided by 2, making it 2.5, I believe. So now let's calculate and see. Let's confirm it for ourselves. Let's say 5 times 100k, it gives us 500. Okay, then 100k plus 100k, that will give us 200. So let's say 500 divided by 200. See, it gives us 2.5. So whenever you see the value of R1 the same with R2, you know that the input voltage just has to be divided by 2, and then the voltage that you get is your voltage out. For example, let's say this line is 1.8 and it has the same, and the R1 value is the same with R2 value. You know that if you divide this 1.8 by 2, it will give us, let's say, if we divide 1 by 2, it will give us 5. Okay, if we divide 8 by 2, it will give us 4. So 5 plus 4 will give us 9. So let's just say 0.9. Okay, it's 0.9. Now, but let's calculate and see. 1.8 times 100 equals to 180. Let's write 180 divided by 200, because 100 plus 100 is 200. So 180 divided by 200 will give us 0.9. All right, so that's the logic behind this circuit when our R1 is the same with R2. Okay, so now let's take another another value. For example, we have our input voltage, let's say 5 volts, okay, times, let's say our R2 is 25k, okay, 25k, divided by R1 should be, let's put 10k plus 25. Let's see what it will give us. 5 times 25, 125, then 10 plus 25 give us 35. So now let's divide this. 125 divided by 35, divided by 35, it gives us 3.5. okay, this is 3.5. So by having these values, we divide this 5 voltage to 3.5. The purpose of this divided circuit is that we want to step down the input voltage. We want to step it down. For example, if we are sending, let's say, less than 5 volts to a certain circuit, or we want our CPU to sense less than 5 volts, and we have 5 volts on this line. So how can we divide it? That sometimes you find a resistor and divide this, but when there is no resistor that can break down this 5 volts to the required voltage you want, you can introduce divided circuit into it, and you will know the values of your R1 and your R2 that will give you the required voltage, output voltage that you want. Okay, so that is how it works. So you can then create a divided circuit to divide this, to break down this 5 volt, or to reduce this 5 volt to your required voltage. So we are done with this single divided circuit. Now let's explain double divided circuit. I said that the purpose of this, our main reason for making videos, is for you to understand how to do it and why you are doing it. Okay, we are not just giving a quick solution here. That's why I take my time to explain these things to you. Most of the times I will show you schematically so that you also understand, so that when you have a fault, you don't just go to YouTube and find a quick solution. A quick solution do works, understand? If you have the same fault, okay, but if you don't have the same fault, what will you do? So you know how to trace it one after the other. So now in our double divided circuit, we have here R1 on series, R2 on series, but we also have R3 that is channeled to ground. So there's a formula here: voltage in times R3 divided by R1 plus R2 plus R3. Okay, for example, let's put values. For example, if we have 5 volts here on our input line, we have 5 volts times our R3. Let's make R3 to be 30k, okay, divided by our R1 should be 65k. Let's put 65k plus R2. Let's call R2 10k, then plus this R3 30k. So let's see the output voltage that is going to give us 5 times 30 will give us 150. Okay, then we have here 65 plus 10 plus 30, so this will give us 105. So 150 divided by 105 gives us 1.4 voltage. So our output voltage is 1.4. There are some models on BAT ID line that you will see double divided circuit. Okay, and how will you know? Your schematics is there with you. So this divided circuit, when you meet double divided circuit, you meet three resistors connected. That is double divided circuit. So this is the formula we are going to use. So let's make one more example. For example, our R1 should be R1, R2, R3. Let's say our R1 is 25k, our R2 is let's put 65k, then our R3 is 100 ohms. Okay, 100 ohms. This one is K, this one is K, this one is ohms. So our formula should be, let's take our input voltage as 1.8 times our R3 is 100 ohms divided by R1 is 25 plus R2 65 plus R1 R3 100 ohms. So now let's calculate this. 1.8 times 100, sorry, 1.8 times 100 will give us 180. Okay, 25 plus 65 plus 100 will give us 190. Okay, so if we divide this, let's see the voltage that it will give us. The output voltage, 180 divided by 190, so this gives us 0.9 volts. Okay, so this is the second example that we are using to calculate this double divided circuit. It gives us 0.9 volts. So I hope this lesson is well understood. Okay, so that is how divided circuit works. I will end here because I don't want to make long videos. I want to make videos that you'll be able to exercise a little patience to watch to the end. So please like this video, subscribe to it, and remember to share this video, because there are a lot of people, technicians, that need to understand how these things works. Not just know it, but understand how it works. So this video will be useful and helpful if you share these videos to them. Okay, so on my next video I'm going to explain a different circuit. So now we are just taking time to explain this thing so that when we start practicing it, you will understand. Whatever we are doing, you will understand it. All right, thank you for watching this video to the end. Remember to like, comment, subscribe, and also share this video. Thank you. See you on my next video.